Got Matt 1033, Chapter 6, Section 2, which is addition and subtraction of rational expressions. Remember what I said before, rational expressions are nothing more than fractions with variables. So in order to add and subtract rational expressions, we've got to get a least common denominator, just like we do with numbers. Come over here. Example 3 has 3 problems in it. It's on page 356. The first problem is right here where it says 2 over x squared y plus 5 over 3x to the third power y. Our least common denominator is the largest number that's in front, which happens to be just a 3. And it's the largest exponential power. Here we have 2 x's, we have 3 x's, so we have to take 3 x's. And we have 1 y, and 1 y, so we only take 1 y. So if we look at this, this is the least common denominator, so we don't have to do anything to it. This, however, we got to multiply by a 3 and an x to get 3x cubed y. When we're dealing with fractions, we multiply top and bottom by the same thing. Same thing with rational expressions. If I multiply the bottom by 3x to get 3x cubed y, I multiply the top. So 3x times 2 is 6x plus 5. Can't reduce it. So our final answer is 6x plus 5 over 3x cubed y. The second one, letter B. We have 3 over x plus 2 plus 2x over x minus 2. Least common denominator. It's x plus 2, x minus 2. This is a factor. The whole thing's a factor. The whole thing's a factor. You can't split that up. So in order to get this x plus 2, x minus 2, on the bottom here, I got to multiply by x minus 2. If I multiply the bottom by x minus 2, I got to multiply the top. Over here, if I want x plus 2 times x minus 2, I got to multiply by x plus 2 on the bottom, which means I got to multiply x plus 2 on the top. So it gives me x minus 2 times x plus 2 on the bottom. On the bottom. Okay? When I multiply 3 times x, I get 3x. 3 times 2, I get minus 6. When I multiply 2x times x, I get 2x squared. 2x times 2, I get 4. Combine like terms and put it in descending order, which is what all polynomials need to be. I get 2x squared plus 3x minus 2 over x minus 2 times x plus 2. See, I get the 2x squared, I get the 3x, and minus 6 plus 4 is minus 2. On to letter C. We've got 2x minus 6 over x minus 1 minus 4 over 1 minus x. Least common denominator, x minus 1. Which means we're going to take this 1 minus x and multiply by a negative 1. When we do that, we get x minus 1 on the bottom. 2x drops, minus 6 drops because we didn't have to do anything to change this. This becomes a minus 4 times a minus 1, which is a plus 4. That's going to give us 2x minus 2 over x minus 1. And in all these problems, you got to check to see if you can factor any more and cancel things out. Here we can do greatest common factor, factor a 2 out. We get 2 times x minus 1. We have x minus 1 on the top and the bottom. They cancel, so to speak, or become 1. So our final answer is 2. This is example 4 on page 357. This is 5k over k squared minus 4 minus 2 over k squared plus k minus 2. I hope you notice that in order to work these problems, I have to factor my denominators. I can't get a least common denominator unless the denominators are in factored form. So this is a difference of squares, so this factors into k minus 2 times k plus 2. This is a trinomial, factors into k plus 2 times k minus 1. Least common denominator is k minus 2 times k plus 2 times k minus 1. We don't write k plus 2 twice. If a factor is in different terms, we take the highest power of that factor in a single term. Because k plus 2 is to the first power here, k plus 2 is the first power here, we stay with k plus 2 to the first power. Had this been to the second power, we'd have taken k plus 2 to the second power. So if we want k minus 1 times k plus 2 times k minus 2 on the bottom, over here we have to multiply by k minus 1, which means we have to multiply the top by the same thing. K times 5k is 5k squared, minus 1 is minus 5k. Over here, if we want k minus 1 times k plus 2 times k minus 2, we're going to multiply by k minus 2. So this becomes minus 2, which gives us minus 2k. This becomes a minus 2 times a minus 2, which is plus 4. Combine like terms, and we get our final answer, 5k squared minus 7k plus 4. You notice that once we get the least common denominator, we don't ever mess with it. Unless, like in this problem, we get something that we get a factor on top that can cancel out with 1 on the bottom. Last example problem. Example 6, page 358. This one has 7 over x minus 1 plus 10x over x squared minus 1 minus 5 over x plus 1. I can't tell you enough how much you've got to know the 5 factoring techniques. They are not going away. They are in chapter 6, they're in chapter 7, they're in chapter 8, they're in chapter 4, which we have left to cover. Alright, so the only one that's factorable is this one because it's a difference of squares. It becomes x minus 1 times x plus 1. So if we look at our denominators, we've got an x minus 1 here, but not an x plus 1. We've got both here. Here we got an x plus 1, but not an x minus 1. So our least common denominator is x plus 1 times x minus 1. If I want that here, I got to multiply top and bottom by x plus 1, which gives me 7x plus 7. I don't have to do anything to here, so I just drop the 10x down. Here, because I have x plus 1, I got to multiply by top and bottom by x minus 1. That's going to give me minus 5 times x, which is minus 5x. That gives me a plus 5, because it's a minus 5 times a minus 1. Again, don't touch the denominator. Denominator stays the same. Combine like terms. Got 7x plus 10x minus 5x, which is 12x. I got 7 plus 5, which is 12. This is factorable, greatest common factor. We can factor a 12 out. If you notice, we have an x plus 1 on the top, x plus 1 on the bottom. They become 1. So our final answer is 12 over x minus 1. You've got to know the 5 factoring techniques that I went over in the video in chapter 5, section 7. And if you don't know them, you have to practice them.